Hi everyone, today we're going to be learning how to program the Rangefinder to control the speaker. So we're going to actually make the code for the Theremin. So to start with, let's create a new sketch. And right away, let's name our sketch. I'm going to name mine Radar Theremin. So Theremin's like there, oops, TH, like there and min together. Okay, so I'm going to say just like that, Radar Theremin, and hit rename. All right, so now we've got it named. Let's get down to business. So first of all, we need to learn how to use the rangefinder. The rangefinder has two important pins for us. The one is trigger pin. That means you're going to send out the burst of ultrasonic sound, so it's going to trigger it. Boom, out goes the sound. 10 microseconds of sound. Then the other side of it, the receiver or the microphone side of it, waits until it hears the bounce back of that exact same frequency sound. So the moment it hears that, the rangefinder will then send a 5-volt electrons down the echo pin so that our friend, the Arduino, can read it. All right, so let's start doing this and see what we have to do. So first thing we need to do is we need to make sure that our trigger pin is set to low to start with. So to do that, we're just going to do a digital write. Just like a digital write for, whoops, there's an L in there. For turning an LED on or off, it's the exact same one here. We're just going to send 5 volts down the trigger pin. So here we're going to need to be able to make something for our trigger pin. So let's come up here and create a variable. And we're going to go int. Let's call it trig pin. And let's set that equal to whatever your trigger pin was. I think I did mine to 5, but your number will likely be different. So this creates a variable and stores the starting value. Okay, and I'm keeping this nice and generic so I can just copy and paste and reuse this comment for all my variables. Okay. All right, and so now I can use trigger pin down here. So I'm going to digital write trigger pin, comma, and I want to write it, oops, low to start with. Right now we're just making sure that the pin is set to low before we send a high command. This step probably isn't that necessary because your pin probably is already low, but it's good to just make sure it is beforehand. All right, and this sets the trigger to off, low. Okay, and now we need to give it just a split second for it to, let me clean up some indent here, to actually set it to low. So we're going to give it a very small delay. And normally we would just use delay parentheses, and that would be milliseconds. We want to use even smaller numbers. We want to use microseconds. So we're going to do delay, capital M, microseconds. Remember, 1 microsecond is 1/1,000,000th of a second. So that's pretty insane. If you spelled it correctly, it should turn green. And we're going to say, let's just give it 2 microseconds to make sure the Arduino has time to get it set to low. That process takes a short, let's see, so very short delay. All right, and the next thing we're going to do is we're going to actually do the same thing, but now we're going to trigger pin to high. Now that we know that it's definitely low, we're going to come back here and set it to high. So I'm going to grab these 2 lines of code actually and just copy and paste them below. I'm going to change the low to high, and this is where we want to send, instead of, we want to send that 10 microsecond chirp, that little burst of sound out. So instead of 2 here, I'm going to go 10. So for those 10 microseconds, the trigger is set to high. And then finally, we need to set the trigger back to low, turn it off. So we've sent our burst, now it's time to turn it off. I'm going to grab this line of code here, and then come down here and put it here. And then let's change some of these comments. So it sets the trigger to on here, and this is high. And then here, instead of just a very short delay, sends out the 10 microsecond chirp. I'm going to put chirp in parentheses. All right, sets trigger to low. So this is all one burst, one chirp. We need all of that code to send out that signal just once. All right, now once we've sent that 10-second signal, we got to tell the Arduino to start, or we have to tell it to start tracking the pulse coming in. And what happens is once that 10 microsecond burst of sound goes out, it travels through the air, hits something, and then bounces back to us. And we need to measure the time it takes from when it ended to when it got back to us. So this is where we're going to use a function called pulse in. What that's looking for, it's looking to see its timing, pulse in, times the amount of time from when the code runs, this line of code runs, to when it receives a signal from a certain pin. In this case, we want to receive it from the echo pin. So I'm going to come back up here. We're going to create a variable called echo pin, and I put my echo pin, whoops, in, I think 7. So there, yours will be different from mine. That's okay. It just needs to match what you wired. So make sure that pin number matches what you actually plugged in. All right, so that's all good. And now I'm going to say pulse in. First thing you put in pulse in is what you're watching. Well, we're watching the echo pin to see when it goes high. And the next thing you put in is what it's looking for. So what this says is measure the time it takes from this point in the code, keep monitoring the echo pin. When it turns high, give me that time back. So how long did it take to do that? And here, // so this records the time it takes to hear the chirp. So boom, goes out, we're recording the time, boom, comes back, we hear the time. The rangefinder has it built in, so this little rangefinder has it built in that when the receiving side, the R side, hears that frequency of sound, it turns the echo pin on here, it sends 5-volt electrons to that echo pin right away. So it says, hey, I heard something, heard something, heard something. And you can track how long that took it by using this code here. All right. Just like all things, this is going to return a number. It's going to give us so many microseconds that have gone by. Arduino will forget that number instantaneously unless we tell it where to put it. So let's call this thing, what are we going to call this variable? We can call it whatever we'd like. Let's call it echo time. Space equals space. So this says, right, wait, start timing, start the timer. Wait for echo pin to go high, and then stop the timer. Then place that time in this thing called echo time. But I haven't created this variable yet, so let's copy and paste this and come up here and create this variable. We're going to be measuring in microseconds, which is millions of seconds. So 1 second is 1 million microseconds. So we actually can't use the int command. It can only store smaller numbers. We're going to use a long variable type. So this is going to use up more of the Arduino's memory so it can store bigger numbers in it. So that's what long is for. It's just like integer, except for really big numbers, which we need here. So I'm going to put echo time up here, and I'm going to give it a starting value of 0, and then I'm going to copy and paste this comment down to here as well. All right, so now we've started our timer, waited for the echo pin to go high, stopped the timer, stored that number in this thing called echo time. Now let's see let's actually see it working. So let's go ahead and do a serial print. So serial dot print ln for a new line, and then we're going to print echo time, and we're going to see how it's working right now. Semicolon, and this print the echo time to the laptop. Now remember, before we can use this, we need to do some setup stuff still. Before we can use this, we need to actually come up here and do serial dot begin at 9600 semicolon. This opens a serial connection between Arduino and laptop. All right. So far, so good. We need to do a few other things, actually. We're using some pins here. We're using trigger pin and echo pin, so we need to do the pin modes for those. So pin mode, and we're going to do trig pin. And this is where we got to think. Is this trigger pin an input or an output? Are we sending out, or are we reading stuff coming in? And for the trigger pin, we're going to trigger, so we're going to send electrons out to start the process with the thing. So we're going to call this one an output. Sets the pin mode. I'm just going to leave it just like that because you can tell it's an output right here. I'm going to do another one of these because we need one for echo as well, because we're using the echo pin as well. So I'm going to come up here and grab echo pin and then paste it right in there. And echo pin, are we sending electricity out, or are we reading it coming in? And for echo, we're reading it coming in, so we need to say input here. Inputs are kind of redundant because all pins are automatically set to inputs to start with, so you really don't need this line of code, but it's nice to have it just to be consistent. I'm going to line up this with the other two, so there's an extra little space in there. And now we should be able to have time to check this out. So we're going to hit space over and verify. Once you have it going over, uploaded, you can open serial monitor, and if everything's wired correctly, you should get really big numbers. Remember, what you're getting is a number of microseconds. So 1 million microseconds is 1 second. So you might be getting things in like 60 or 70,000. If it's not working, it's probably a problem with your wiring. Make sure you check that out. In the next video, we'll pick up here and we'll learn how to then change that or measure the distance, and then also how to then convert that into a tone. All right, have a good one, my friends.